Section 1.3 is on measuring and constructing angles. So we're going to start off with 4 vocab words here. The first one is angle. And an angle is formed when 2 rays connect at their endpoint. So here is an angle. And both rays start at this point and reach out away from each other. The vertex is where the 2 sides of an angle meet. So this point down here, the end point of both rays, is the vertex. And then the interior of the angle is all the points inside of the angle. So here is the interior of the angle. And the exterior of the angle is all the points outside. So anything that lies out here is exterior. It's outside the angle. So example 1, a surveyor recorded the angles formed by a transit, which is point T, and 3 distant points, Q, R, and S. And they want you to look at this picture and name 3 different angles. So the first angle that I see is right here. And when we write angle names, we have to write the angle sign. And then you got to start at one of the outermost points. So in this one, I have to start with either Q or R. It doesn't matter. But from Q, so if I start with Q, I'm going to go to T and then to R. I could call that angle RTQ as well, but as long as that T is in the middle because it's vertex, then you are good to go. The other angle is right here. And we can call that one RTS, or we could call it STR. And then for the third angle, it is the large angle here, and we can call that one angle QTS or STQ. Measure is usually given in degrees, so when you're asked to find the measure of an angle, it's normally given in degrees, and a degree is 1/360th of a circle. And keep in mind, a circle is 360 degrees, so 1 degree is 1 out of 360 of those. Postulate 131 is the protractor postulate, and it's saying that given AB and a point O on AB, all rays that can be drawn from O can be put into a 1-to-1 correspondent with real numbers from 0 to 180. I drew that in a picture. I would have line AB, and there's a point O somewhere on that. And it says all rays that can be drawn from point O can be put into a 1-to-1 correspondence with the real numbers from 0 to 180. So if I drew a ray out here, we can say if I measured that, maybe that angle is 30 degrees. And then if I drew a different one, if I did one straight up and down, then that angle would be 90 degrees. If we drew one out this way and we were looking at this angle here, then maybe that's 120 degrees. So no matter what we do, we're going to have an angle that's anywhere from 0 to 180 degrees. Here are 4 types of angles. An acute angle is less than 90. A right angle is 90 degrees exactly. An obtuse angle is more than 90. And a straight angle is exactly 180 degrees because it forms a straight line. Example 2 says find the measure of each angle and then classify it as acute, right, or obtuse. So it goes through that protractor at 140 degrees as well, but that would be if we were measuring on the other side. So if it was open wider. So you can see that this one is less than 90. It's smaller than a 90-degree angle, so we know we have to use that 40 degrees. The other angle that they want the angle measure on is angle COD. So COD would be right here. And that looks like it goes through at 15 right here. So, and this one goes through at 105. So it is 15 degrees less than 105 because that 105 is actually from this straight line down here. So if I do 105 minus the 15, I get 90. So this angle is actually a 90-degree angle. And if we classify it, that would be a right angle. And the 40-degree angle is less than 90, so that would be an acute angle. Congruent angles are angles that have the same exact measure. So yesterday we talked about the tick marks and how they represented congruent segments. So those are on these triangles as well. One tick mark matches up with one tick mark on the other triangle, and 2 and 3 and so on. So the same thing works for angles, but they use the little arcs there. And so this one has 1 mark, so it goes with the 1 mark over here. This one has 2 arcs, so it goes with 2 arcs over here. And this one has 3 arcs, so we know it goes with the 3 arcs on the other triangle. So that's how we show congruent angles in a picture. All right, congruent angle, constructing a congruent angle. So you're going to start off with a straight edge to draw a ray with endpoint of D. Then you're going to place a compass point at A, so up here in the original picture, and draw an arc that intersects both sides of angle A and label the intersection points B and C. So that's what they did here. So on the original picture, they drew an arc and labeled points B and C. You're going to use the same compass setting, so you're not going to open or close that compass anymore, and place the compass at point D and draw the arc that intersects the ray. So back to your number 1 picture there, put the point down at point D and draw an arc. Label the intersection E. So now you have a spot where it crosses your line, where it bisects your line. Then you're going to place the compass at point B, so back on step 2, and open it to the distance of B to C. So from how wide that angle is open, there's how wide you're going to open the compass. Place the point of the compass at E. So back to your new picture, you're going to put the point on E and draw an arc and label the intersection with the first arc F. And then you're going to use a straight edge to connect your point D to that new point of F that's out there. And then angle D would be congruent to angle A. Postulate 132 is the angle addition postulate, and it says if S is the interior of angle PQR, so if we look at our picture here, we have the large angle is PQR, and then we have that line going throughout the middle there with S, then the measure of angle PQS, which is shown in red, plus the measure of angle SQR, which is shown in blue, is going to be equal to that larger angle. So basically the 2 smaller ones inside put together are going to make your larger angle. So for example 3, it says the measure of angle ABD is 37 degrees. So if I draw that, ABD, and this one is 37 degrees, the measure of angle ABC is 84. So AB is already shown here, so we need another angle out here, that's C, and that is going to be 84 degrees. So they share that side AB. Find the measure of angle DBC. So D to B to C, they want that larger angle? Well, it's those two smaller ones put together. So we just add those two numbers, 37 plus 84, and you get 121 degrees. An angle bisector is a ray that divides an angle into two congruent angles. So I'm going to try to draw the best I can here. So we have a 90-degree angle. A angle bisector is one that's going to go right through the middle. And so you have two 45-degree angles. And that could work with, starting with a 20-degree angle, and you have a bisector that's going to make two 10-degree angles. It doesn't have to be a 90-degree angle. All right, so to construct a perfect bisector, you're going to use a compass, and you're going to place the point of the compass at A and draw an arc. So you're going to take the angle they gave you, and you're going to draw an arc somewhere out there. Label its points of the intersection with angle A as B and C. So as shown in the picture, you're going to label those two spots B and C. Without changing the compass setting, so you're not going to open or close it any farther, you're going to draw intersecting arcs from B and C. So you're going to put the point of the compass on C and draw an arc out there, and then do the same thing, put the compass point on B and draw an arc out there, and make sure you extend them enough that they cross. You're going to label that intersection as point D, and then you're going to use a straight edge to draw a line from point A out through that point D, and that would be your perfect bisector. And example 4 says that BD bisects angle ABC, and the measure of angle ABD is 6x plus 3. So this is 6x plus 3 right here. And DBC is 8x minus 7. So this one's 8x minus 7. Find the measure of angle ABD. If that segment BD, or that line, bisects it, that means that these two angles are congruent to each other. So I can say 6x plus 3 is equal to 8x minus 7. So then we're going to have to solve. We're going to minus 6x from both sides. And we're going to have 3 equals 2x minus 7. Then we're going to add 7 to both sides. So we're going to have 10 equals 2x. And then we're going to have to divide both sides by 2. And we get x equals 5. And they didn't ask us what x is. They asked us what is the measure of angle ABD. And that was our 6x plus 3. So 6x plus 3, we have to solve for that. And we just figured out x was 5. So 6 times 5 plus 3 would give us 30 plus 3. So that angle is going to be 33 degrees.